I am Dr.G.B.Chandra Mouli, Assistant Professor of Mathematics, Freshman Engineering Department, Aditya University. Learning outcomes. At the end of this lecture, student will be able to know different types of differential equations, identify order and degree of differential equations, and know about solution of differential equations. Definition of differential equation. An equation involving derivatives of one dependent variable with respect to one or more independent variables is called a differential equation. Generally, when we represent a function, when we denote a function, y is equal to f of x. Here in this function, y is the dependent variable and x is the independent variable. So, here y is a function of single independent variable, and sometimes we deal with functions of more than one independent variables, like z is equal to f of x comma y. In this case, z is the dependent variable and x and y are the independent variables. There are two types of differential equations. One is ordinary differential equations, second one is partial differential equations. Definition of an ordinary differential equation. A differential equation is said to be ordinary if the derivatives in the equation are ordinary derivatives, which means we have derivatives of one dependent variable with respect to one independent variable. Such derivatives are called ordinary derivatives. Examples of ordinary differential equations. Equation 1, dy by dx plus 2y is equal to sin x. So, in this example, we have the derivative dy by dx. So, here we have one dependent variable, that is y, and x is the independent variable. And in the second equation, in this representation, x square plus y square minus x into dy plus y into e power y minus 2xy into dx is equal to 0. So, in this also we have a derivative. So, it is a differential equation. The third one, d square y by dx square plus 5x dy by dx minus 9y is equal to e power x. Okay. So, in this equation we have dy by dx as the derivative, d square y by dx square as the derivative, okay, and this is also an ordinary differential equation. So, in all these equations we generally treat x as the independent variable and y as the dependent variable. Partial differential equation definition. A differential equation is said to be partial if the derivatives in the equation are partial derivatives, that is derivatives of one dependent variable with respect to more than one independent variable. So, such an equation is called a partial differential equation. Examples of partial differential equations. In the first one, dou u by dou x plus dou u by dou y is equal to 0. In this equation, the dependent variable is u and the independent variables are x and y. So, u is a function of x, we represent like this, u is a function of x and y. That means u is the dependent variable and x and y are the independent variables. In the second equation, which is generally known as one dimensional wave equation, which we generally come across in the case of one dimensional vibrating string problems or vibrating string problems, the equation is dou square y by dou x square is equal to 1 by c square dou square y by dou t square. So, here in this equation y is the dependent variable which is a function of x and t, which are independent variables. And in the third example, which is again famous partial differential equation, which is one dimensional heat conduction equation. We come across this in the case of heat flow in a rod. In this equation, u is the dependent variable, which is a function of x and t. So, we have two independent variables x and t and one dependent variable u. And in the fourth equation, which is also a famous partial differential equation, which is two dimensional Laplace equation, which is dou square u by dou x square plus dou square u by dou y square is equal to 0. In this equation, u is the dependent variable and the independent variables are x and y. So, we have one dependent variable u and two independent variables x and y in this equation. Order of a differential equation. A differential equation is said to be of order n if nth order derivative is the highest order derivative in that equation. So, we will see this in the following two examples. In example 1, dy by dx plus 2y is equal to sin x. In this equation, we have only one derivative, that is dy by dx, and the order of this derivative is 1. dy by dx is a first order derivative. So, it is the highest derivative in the equation. So, the order of that derivative is 1, which is the order of the differential equation. And in example 2, d square y by dx square plus 5 dy by dx minus 9y is equal to e power x. We have two derivatives, dy by dx and d square y by dx square. dy by dx is of order 1, first order derivative, and d square y by dx square is a second order derivative. And in these two, d square y by dx square is the highest order derivative, and so the order of the differential equation is 2. So, a differential equation is said to be of order n if the nth order derivative is the highest order derivative in that equation. Degree of a differential equation. The degree of a differential equation is the highest degree of the highest derivative which occurs in the equation. So, it is the degree of the highest derivative which is present in the equation after the equation has been made free from radicals and fractions as far as the derivatives are concerned. So, before finding the degree of the differential equation, we have to remove the radicals like square roots and cube roots, and we have to remove the derivatives from the fractions. We will see the degree in these two examples. In the first example, a d square y by dx square is equal to 1 plus dy by dx whole square whole power 3 by 2. So, in this we have power of 3 by 2 which we have to remove before finding the degree of the differential equation. For that, we square the equation, taking the square of the equation on both the sides will give you a square d square by dx square whole square is equal to 1 plus dy by dx whole square whole cube. And in this, we have two derivatives, dy by dx and d square y by dx square. The highest is d square y by dx square, highest derivative, highest order derivative, and the degree of that derivative is 2. So, after removing the radicals from the equation, we are identifying the degree of the differential equation. So, here 2 is the degree of the highest derivative d square y by dx square, and it is the degree of the differential equation. 2 is the degree of the differential equation. We will see one more example. So, y is equal to x into dy by dx plus square root of 1 plus dy by dx whole square. So, in this we have a radical sign whole square root of which we have to remove before finding the degree of the differential equation. For that, we write this x dy by dx on the left hand side. So, it will be y minus x dy by dx on the left hand side, and then we do square of the equation on both sides, and left hand side will be y minus x dy by dx whole square. On expansion we will get this, and now writing the terms in an order, we get 1 minus x square dy by dx whole square and 2 plus 2xy dy by dx plus 1 minus y square is equal to 0. So, in this we have first order derivative dy by dx, and that is the highest order derivative. Dy by dx is the highest order derivative, and the degree of this dy by dx is 2. The degree of dy by dx is 2, which is the highest power of dy by dx. Here dy by dx the power is 1, and here the power of dy by dx is 2. So, the highest power of dy by dx is 2 in this equation. So, the degree of the equation is 2. So, this is about degree of differential equation. So, before we find the degree of a differential equation, we have to remove the radicals, we have to remove the derivatives from the fractions if any, and then we have to identify the degree of the equation. Next, solution of a differential equation. Any relation between dependent and independent variables not containing the derivatives and which satisfies the differential equation is called solution or integral of the differential equation. Once again, any relation between the dependent and independent variables not containing the derivatives which satisfies the given differential equation is called solution or integral of the differential equation. I will explain this in this example. So, consider the equation d square y by dx square plus y is equal to 0, and I am writing a relation between y and x here as y is equal to c1 cos x plus c2 sin x. So, we will see whether this y is equal to c1 cos x plus c2 sin x satisfies the differential equation or not. So, the left hand side of the differential equation is d square y by dx square plus y. So, I am substituting y in this. So, d square by dx square of y, which is c1 cos x plus c2 sin x, plus y, which is c1 cos x plus c2 sin x. So, differentiating 2 times c1 cos x plus c2 sin x, so we will get, so if we differentiate once, we will get c1 into minus sin x, which is the derivative of cos, and plus c2 into derivative of sin x is cos x. This is what we get after differentiating once. If we differentiate again, we will get c1 into minus cos x plus c2 into minus sin x, and the next term is c1 cos x plus c2 sin x. So, here c1 cos x plus minus c1 cos x gets cancelled, and c2 sin x minus c2 sin x gets cancelled, and you will get 0, which is the right hand side of the equation. So, when you substitute y is equal to c1 cos x plus c2 sin x in the differential equation, so we get this left hand side is equal to right hand side. So, y is equal to c1 cos x plus c2 sin x satisfies the equation, and so it is the solution of the differential equation. So, any relation between the dependent variable and the independent variable which satisfies the differential equation is called solution of the differential equation. Next, there are different types of solutions. One is general solution of a differential equation. So, a solution containing number of independent arbitrary constants, which is equal to the order of the differential equation is called general solution of the differential equation. So, the number of arbitrary constants in the solution, if it is equal to the order of the differential equation, then such a solution is called general solution of the differential equation. I will explain this in this example. Again, the same differential equation is considered, d square y by dx square plus y is equal to 0, and we have seen that y is equal to c1 cos x plus c2 sin x is solution of the equation, and in this solution there are two constants c1 and c2. These c1 and c2 are arbitrary constants, which means they can take any real constant value. So, arbitrary constant means they can take any real constant value, and there are two arbitrary constants in this solution, and the order of the differential equation, okay, is equal to 2. d square y by dx square is the highest order derivative and its order is 2. So, order of the differential equation is 2. So, y is equal to c1 cos x plus c2 sin x has two arbitrary constants, and the order of the differential equation is 2, which means that this solution is general solution of the differential equation. Next, particular solution of a differential equation. A solution obtained from the general solution. A solution obtained from the general solution of a differential equation by giving particular values to the arbitrary constants is called particular solution of the differential equation. Again, we will see this in this example. The same differential equation d square y by dx square plus y is equal to 0 is taken, and we have seen that y is equal to c1 cos x plus c2 sin x is general solution of the differential equation. And in this, if we give particular values to the arbitrary constants like c1 is equal to 2 and some c2 is equal to 3, any arbitrary, any constant value, then the solution becomes y is equal to 2 cos x plus 3 sin x, and which is particular solution of the differential equation d square y by dx square plus y is equal to 0. So, we have seen the types of differential equations. Mainly we have ordinary differential equation or simply differential equation and partial differential equation. These are the two main types of differential equations, and we have seen order and degree of ordinary differential equations and different types of solutions of the differential equations like general solution. First we have seen what is a solution, then general solution and particular solution of the differential equations. Thank you.